finding local extrema. So this was the idea that we were given some sort of formula for f, and we want to be able to find coordinates of quote-unquote critical points. So we define critical points as points on the graph of f where the slope is 0, or you could say it has a horizontal tangent. The graph is flat. Now we did that because it was kind of the first step for recognizing local maximums or minimums. We realized that if we want to find a local maximum, then at that point, the derivative is 0. The graph is flat. So first, if we want to be able to find these points, then we can start off by finding these critical numbers. There was one more case of a critical number that was neither a local maximum. So it's this idea where at this point, the graph is flat, so the derivative equals 0, but it is neither a local maximum or local. So for Calc 1, if we wanted to find critical numbers, that is where the first derivative equals 0. So start off, just take the derivative of f of x. And we want to find the values of x that make that first derivative equal to 0. So that's 6x squared plus 6x minus 12 equals 0. I'm going to solve this by factoring. It looks like there's a 6 in everything. Two numbers that multiply to negative 2 and add to 1, positive 2, negative 1. So I get x equals negative 2 and x equals 1. Now the next part says classify each critical point as a local maximum, a local minimum, or neither. And the way that we were able to do that is using the quote-unquote second derivative test. So our logic or reasoning here was, let's look at that first example of a local maximum. At that local maximum, the first derivative equals 0, so that looks pretty good. But it is also true that this function is concave down. In other words, our second derivative is negative. So in Calc 1, we realize that if the first derivative equals 0, and the second derivative is negative, then you have a local maximum. If your first derivative equals 0, but now you're concave up, so your second derivative is positive, that would be a local minimum. And if we have a critical number, our first derivative equals 0, but our second derivative now is, I'm actually sitting at an inflection point. I am neither concave down nor concave up. I'm at a beautiful part where we transition. So if your first and second derivative equals 0, that was our neither case. So now I'll give you guys a 20-second head start. Now you have these critical numbers, x equals negative 2 and x equals 1. Determine if those are local maximums, local minimums, or neither. And you want to use the idea of the second derivative.